Parent graphs. Ooh, looky here. Aren't you glad your parents don't look like that? Or maybe they do. That was embarrassing us, but yeah, we do love our parents. All right. First off, we have the constant. This is actually a linear function, but even more specific in the linear function, this one has a unique name called the constant function. Because it's a horizontal line and it's just y equals 2. Like, doesn't matter what x is, x can be 5, y is 2. X can be negative 3 million, y is 2. Right? The next one is, this one's still a linear function, and this one is also the parent function we call y equals x, sometimes called the identity function. There's no, by this we have no horizontal or vertical shifts here, and it makes a line. So linear ones make lines. Those are pretty easy to remember. Line, linear. Ooh, these V-shaped ones are absolute value functions, which are written like y equals the absolute value of x. And if you think of positive 1, the absolute value of positive 1 is 1, but the absolute value of negative 1 is also positive 1. But it makes a V-shaped, all right? This one's a square root function. Square root, and you can see it makes what the square root looks like. And the reason there's no negatives, because if you have a negative x, you can't square root it. It makes an imaginary number because it doesn't exist. So we have a square root function here. It looks like this here, the following. Ooh, quadratic. This is the one everybody forgets. Quadratic function. Think 1 times 1 is 1. Yet negative 1 times negative 1 is also 1. So it's a quadratic function. Oh, I like this one. This is the cubic. 1 times 1 times 1 is 1. But negative 1 times negative 1 times negative 1 is negative 1. So I think the trash truck's outside. That's what I'm hearing there. All right. The cubic function. All right. Also, the cubic function is, I sometimes think it's y equals x cubed. That's why it's 1 times 1 times 1. Also, call it look like an Egyptian. All right. And the reason I say that on that one is because one side is, if you notice, one side is always up and one side is always down. So that's why I call it walk like an Egyptian, because they walk with the one hand up and one side. Oops, we're going the wrong way there. That's why I call it walk like an Egyptian. Ooh, this one's the irrational function, which is 1 over x. It has what we call asymptotes. You can't touch this. We'll talk more about that when we deal with irrational functions. But basically, they're the variables in the denominator. And it makes a graph kind of like this here. That's a rational function. So I like to think of that one, but the irrational function. We'll come back and visit that later. Here we have an exponential function, which means the variables in the exponent. We'll cover this probably at the end of the year. And it notice there are no negative y values on this particular one, but a negative x makes, in sense fraction, really tiny numbers. It goes to infinity out here and it goes to infinity to the top. And then we have the logarithmic function, which is the inverse of the exponential one that we just saw. And it on this one here, notice there are no negative x values in this one. Those are the parent graphs that we will be looking at and studying this year. So you kind of know what they look like. You might want to look back at this one at some time to look over